Right, everybody. Question number 8. So I hope you read the question and understood, because I shared my videos with one of my friends and he said that you are reading very fast and it's not clear. But I assume that my students already read that and understood. Okay, there are some students. Actually, it's very important how many students. Okay, they tested when they admits the mathematics department in the university, and then after 3 years they tested again, and here's the result. And it says that here, stating your hypothesis, use an appropriate test to investigate at 1% level of significance whether or not there is an association between performance. So that means, so we have chi-square test. There are two kind of chi-square tests, right? Goodness of fit is this, we expected values and observed values, and test for independent. It says, actually, just look at this data and then tell us, are they dependent or independent? What we need to do, first of all, we need to find actually how many students are there, right? So I will tell you the common mistake. Okay, and we need to find the total students for each column and row, right? Here is 35, 40, 43, right? So here is, I actually add them before, but I forgot, 32, and then here is 20, 25, and then here is 20, 50, okay, 13, 25, okay, and then here is 25. Okay, the common mistake is my students are adding them up here and then adding them up here and then write it down here 200, which is wrong. How many students are there actually? Just first class, second, okay, first class, second class, and third class. How many students are there? 100. Or excellent, very good, and good, how many? 100. There are only 100 students are there. Now what we're going to do, we are going to create another column. Okay, are they independent? So we think that there is no relation. Okay, and then after 3 years we think that if there is no relation. If there is no relation, that means, so excellent is gonna be here.
Let's say excellent, very good, and then good. Okay, here is the first year, and then here is the second, and then here is the third. So what we said,
if you think that there is no relation, that means it's a Dreisatz, right? So before, but the easiest way, just multiply these two and then divide it by 100. So this column is going to be 43 times 50 divided by 100. So this column is going to be 32 times 50 divided by 100. So 32 times 50 divided by 100. Okay, H null hypothesis. We said that they are independent. So there is no association between them. So alternative hypothesis says no, they are dependent. There is an association. So there is an association. So what? All right, to do the chi-square test statistic, we just go to the statistic, then test, and then chi-square test. This is goodness of fit, and this is dependent or independent test. So we need to write it down, those matrices, right? So those tables as a matrices. So the first matrix is observed one, and the second one is the expected one. So we already did the expected one, we just need to type this in. So go to the math, okay, the observed one. So this is 3 by 3, right? Yep. And write it down, the observed values. So which is 30.
okay, and then 14, and then 6, 8, oops, 14, 6, and then 8, and then 12, and then 5, and then 5, then 6, then 14. Okay, that's it.
Exit. Again, B matrix is all 3 by 3. This is the expected one. So we already calculate the expected one. Let's write it down.
21.5, 16, 12.5, so 10.75, oops, made a mistake, 10.75, 8, 6.25, 10.75, and 8, then 6.25.
That's it. So we are done. Go back to exit. Now everything is, the observed values are done, expected values are done. So calculate it and look at the p-value. This is very, very low. What is our p? The p-value we found it, so it's 1.19 times 10 to the minus 4. That means very, very less than the p-value, less than the alpha. That means, so think about the chi-square. Let's say this is the 1% here, so 0.01, and then your test statistic over here. This area stands for the H null in confident interval, right? So what we do, we accept the alternative hypothesis. There is no association.